Do you want to set up a skybox with an HDRI in your scene, but you're struggling and don't know how to go about it? So
don't worry, I've prepared a quick and efficient tutorial for you.
Let's get started. For this occasion, let's go back to our scene where Mario showcases acrobatic skills. Feel free to check out the corresponding video in the description. The goal here is to set up a skybox, which is actually a simple mesh using a specific material based on an HDRI image. To start, let's focus on the HDRI in question. I downloaded one from the Space Sphere Maps site. There are other possibility websites too, like Polyheaven, which offers many free HDRIs. Once downloaded, you need to ensure that the format is .HDR. This is very important for the overall setup. We could use a .EXR format, but the setup will be different and a bit more complex to implement. We'll cover that in detail later. Import your HDRI into your Unreal project, and you'll automatically see the conversion of your image into an asset type called Texture Cube. Note this is not a simple texture. Subtleties in creating our material will come into play. Now that we have our HDRI, let's create a material to set up all the necessary logic, which will later apply as a material instance on our future mesh. The first thing to do here is to change the shading model to unlit. This will allow us to focus solely on the emissive input of our material. It will also simplify the general reaction in terms of the scene's lighting and certain attributes that we will need to address on our mesh later. Let's move on to constructing our material. First, bring our HDRI texture into the graph. If we try to connect it directly to our emissive input, we'll get this error message. And this is likely why you wondered how to do it and how to fix it quickly. Simply put, our error message mentions that we need to specify UV coordinates on our texture because, as is, Unreal doesn't understand how to use our texture in our material. If you try using the classic UV coordinate node, it won't work. Our HDRI is a texture cube and needs coordinates specified as UVW, and not just UV with two coordinates as we are used to using on classic textures. This is why you likely had trouble defining the UV coordinates of your HDRI. I mentioned earlier the .EXR format and some of its drawbacks. Here, if we used an image in .EXR format, the classic UV coordinate node would work, but we would encounter this issue of scaling our UVs. It would be complicated and all the problems would arise as well. To correctly specify our UV on our texture cube, the simplest way is to use the absolute world position node. If you connect its XYZ outputs to the input UVs of our HDRI, it works and the UVs are correctly specified. XYZ here can refer to the float 3 type required on our texture cube, which is the famous UVW. As you can see on the preview viewport, it works perfectly. The last step for our material is to add controllers to adjust our HDRI via a material instance as we like. Before that, we can set up a mesh in our scene to act as Skybox and later receive our material instance. Here I use the sphere quickly created via the modeling mod, but you can also use the primitive sphere from Unreal directly. Just make sure to place it at the absolute center of your scene. Remember, we are using the absolute world position node here. Otherwise, you will get distortions in the UV projection of your sphere. Create a material instance from our initial material to assign it to our sphere. We'll detail our instance right after. Scale your sphere to encompass your scene and don't forget to disable the cast shadow attributes in its details panel. We can now add any other light source inside our mesh without any issues. Back to our material, the first thing we can define, for example, is the rotation of our HDRI relative to an axis. The ideal node here is rotate about axis, since it involves a 3-channel vector input, exactly what we need here. The first thing we can connect here is our absolute world position to the position inputs. We specify this here to tell Unreal that we will be rotating our texture from the world position, but we still need to specify this at the initial UVW coordinate. Therefore, additionally via our add node, we will independently use our absolute world position along with our rotation system. Congrats guys, the hardest part is done. For the pivot point inputs, we can connect a simple constant with the value of 0. We won't modify this value later. However, we need to specify it here. Right-click on the rotation angle inputs to adjust it on the fly via our material instance. Let's rename it HDRI rotation, for example. For the last input here, I create a vector parameter using the shortcut V plus left click. The RGB values will refer to the XYZ vectors values. We can later determine one or more axes as we like on our instance. To start here, specify only the Z-axis in rotation by adding a value of 1 to the blue channel. So now let's test our parameters via our material instance. As you can see, we can easily orient our HDRI and specify an axis other than Z and even combine them. The finite possible adjustments will be to play with the contrast, brightness and an additional tint of our HDRI. To do this, it's very simple. We could use a power node with a factor we'll adjust in our instance using a scalar created here with the shortcut S plus left click. For brightness, we'll use the same setup but replace the power node with a multiply, like a classic emissive setup. The same goes for the tint, except we'll use a vector parameter instead of a scalar parameter. And there we go! If you go to your instance now, you'll be able to control all the parameters we set up together and adjust your HDRI as you desire. And that's it guys, I hope this video helped you demystify the HDRI Skybox setup. If you have other suggestions for setups that seem complex to implement in Unreal, I'm open to them, let me know. Don't forget to like and subscribe, it's very important for the channel and I thank you in advance. So see you soon and ciao!